Hello, my young urban mathematicians. Today's topic is going to be on greatest common factor. I'm going to change this up and use another dry marker. So the topic is greatest common factor. They also call it divisor. When I was a kid, it was GCF. So now they have GCD. Back in my days, GCF, greatest common factor divisor. All that means is the largest number that the largest whole number that two whole numbers share in common. That's a factor of it. And so let's talk about all that fancy talk and put in some easy to understand terms. Let's say I have the number, and we'll start with a very simple number. Let's say I have the number 4. And I have the number 2. If I was to lay out the factors, or the numbers that can be multiplied to equal this, you would see I could have 2 times 2. Here, I'd have 1 times 2. Now, the reason why I do 2 times 2 over here as opposed to 1 times 4 is because if I do 1 times 4, notice 2 times 2. So this is sort of unusual to even put the 1 here, but I just want to give you an understanding what they have in common. If we look at these numbers here, we can see that the largest number they have in common is 2. So the greatest common divisor or factor would be 2. Let's put that to the test, the idea of the greatest common divisor. So if I have 4 here, what would be the largest number I could divide 2 by and 4 by? You guessed it, 2. So we go there. Quotient of 2 and 4 is going to be 2. The quotient of 2 and 2 is going to be 1. So you can see that 2 is the largest same number that they share that I could divide evenly into those numbers. Let's try another one because I really want you to understand this topic. So let's progress up to a little bit of a larger number. Let's try 6 and 15. So we'll separate it out. We could go 1 and 6. We understand that that's sort of redundant. So we go 2 or the same thing over and over. 2 times 3, and I'll go here. And I'll go 3 times 5. They have some prime factors. Here's a prime factor, here's a prime factor, here's a prime factor, here's a prime factor. We're not really concerned about the prime factors in this situation here. I'm just trying to demonstrate to you that you can see the largest number here, 3. Well, let's see if that's true. Can 3 go into 5 evenly? How many sets of 3 can? 5 sets. And we go over here. How many sets of 3 can go into 6? 2 sets. That'd be the largest number. Notice here if I try to do 5 on 15, that'd be nice. But then notice when I go over here, 6, 5, that doesn't give me an even number. You can see I get 1 1/5 or 1 2/10 in that situation. So it doesn't pan out. If I try 2, so we done the 5 over here. Let's try the 2 over here and try it over here. That's going to work, of course, for the 6. But you can see if I try the 2 over here with 15, it's going to give me 7 and 5/10. So you can see how we have to use this 3 and 3 here. When we try to divide by the other numbers, they just don't give us whole numbers. Look, decimal here, and decimal here. So we can see it doesn't work. Largest divisor or factor out of the set that we can divide into 6 and 15 evenly would be 3. If you're a little confused by this idea, go ahead and just take a look back. I know sometimes I speak a little fast. So go back once again, greatest common divisor or greatest common factor, the largest factor, or you can think of it as a divisor. I like to think of the largest factor that can be divided evenly into 2 or more numbers. So notice here, some factors laid out for you. I got a 3 and a 3 here. I do that in that situation. All right, so let's go ahead. Let's try one more. Where it's just not that easy to see right away. Let's try 8 and 24. Well, let's do prime factorization just to see. 2 times 4, 2 there, And then I have, what is that, 6 times 4? 2 and 2, 2 and 3. There are other ways. Remember, we could go 3 and 8 in that situation. I'm just choosing that route just because. So if I go over here, this one's a little more interesting. Notice when we laid out the factors, they were all prime and we didn't have to do anything because that was the largest number. Notice here I have some ones in common I have. So primes. And notice what I have here as well. These are all in common. 1, 2, 3, 4, 5, 6. So it looks like I can take 8 here. I can take 8 here. Let's see if 8 would be the largest number that could go into 8 evenly. Looks like it. Okay. And is that large one I can go into 24 evenly as this? Looks like it. So you can see, you're not always just finding one prime factor and going back and saying that's the one. Sometimes you take these prime factors and bring them together. I just wanted to show you this. We'll talk further about this idea, but I want you to see that it's just the largest number that can be taken on each one, or factor that can be divided between both of these. Notice your large number is going to be 8. We can see that. We can also see it from the prime factorization. So we're going to go to the next video and actually find the greatest common factor divisor using 2 different techniques that you can choose.